Hello everyone, I'm forecaster Jack Sillin here to take a look at the severe weather setup forecast to take shape across parts of the Mid-Atlantic tomorrow, which is Saturday, May 12th, 2018. So here's a look at our water vapor satellite imagery from GOES 16 this evening. You can see the pattern dominated by a large upper level low dropping to the south across parts of the Rocky Mountains. We have some severe thunderstorm activity this afternoon here across parts of southeastern Wyoming. No major impacts expected from those storms as they move off to the northeast tonight. The system we're going to be watching really closely over the next 24 to 36 hours is this system moving through the Chicago area right now. That will be moving off to the east-southeast throughout the night tonight, arriving in the mid-Atlantic tomorrow, and that's where it will drive some severe thunderstorm activity that is expected to be a little bit more widespread and a little bit more significant, with damaging winds, large hail, and tornadoes all possible. So I'm going to dig into the setup here, looking at what to expect from these storms, as well as some of the science behind the setup. So heading on over to our GOES East visible satellite imagery on a little bit more of a regional scale. You can see here's our disturbance to watch that is moving across parts of Michigan this evening. Clear skies to the south of that, you can see in here, and there's a bit of a contrast setting up kind of along a frontal boundary, drapes generally in this area, and I'm going to show you that right here with our temperatures this evening. A remarkable contrast across parts of the Midwest. Temps in the mid-80s here in central Indiana, and just a few miles to the northeast, you're in the 50s. So pretty remarkable temperature contrast along that frontal boundary. And this area of sharply contrasting temperatures will be moving off to the east-southeast along with that disturbance, and that is expected to arrive again in the mid-Atlantic tomorrow. Looking at our ECMWF's temperature forecast for tomorrow on weathermodels.com, you can see exactly what I'm talking about. Temps in the DC area in the 90s, 80s in the Baltimore to Philadelphia corridor, and then as soon as you get to the northeastern side of that frontal boundary, you're looking at 50s in the New York, northern New Jersey area. So this sharp temperature contrast will be the trigger mechanism for severe thunderstorms. Again, the stage set kind of favorably in the background by that disturbance we talked about over Michigan. And then the trigger mechanism will be this frontal boundary right here. You can see that extends back across Pennsylvania and into Ohio. So severe thunderstorm activity also expected there. Another thing that'll be working in favor of that temperature boundary, or that temperature gradient, will be the cloud cover contrast. So we saw in that satellite imagery here, cloudy skies over Michigan, kind of to the north of that front, and then sunnier conditions farther to the south of that front. That contrast is going to exist again tomorrow. Here's the NAM-WRF's to cloud cover forecast, and you can see clear skies expected, mostly sunny from DC to Baltimore, breaks of sun in the Philly area, and then just to the north of that, mostly cloudy skies here in the New Jersey, New York area. Steadier rains expected up here where there's less in the way of instability. But these sunny skies will be generating plenty of instability, and so look for plenty of fuel for those severe thunderstorms, and we can actually see that in our Cape forecast here. Plenty of Cape developing here. Not nearly as intense as you'd see over parts of the plains, for example, but values in these lighter blue colors here, over 1,000 joules per kilogram, enough to support some severe thunderstorm activity. Taking a closer look at our ECMWF's thunderstorm composite map, again, we can see this instability here. This is 5 o'clock tomorrow evening. Values in the reds and oranges, again, near and above that 1,000 joules per kilogram threshold, so supportive of severe weather. And if we click the map to zoom in, then click near the edge to pan back up into our area of interest, we can take a closer look at some of the wind profiles. So surface winds will be determined by the exact location of that boundary, and I'll show you that in a minute because they're going to be important for another portion of the threat here. But what I wanted to show you was the fact that our boundary is oriented from west to east, and the winds are blowing from west to east throughout most of the atmosphere. A little bit of a northwesterly component to the blue arrows here. Those are the upper level winds. And then perhaps a little bit of a southwesterly component to the surface winds, but by and large mid-level winds out of the west. You can see these green arrows here, almost due west. So the shear vector tomorrow will be pointed parallel to the boundary of initiation, What does that mean? Well, we're looking for a line of storms to develop. So the storm mode will not be discrete or supercellular, but instead will be more of a line of storms. Now, that line of storms could have embedded supercell type structures within them, and those will be the cores that will produce the most intense thunderstorm activity. Those cores are where you're going to expect your damaging winds and large hail, along with potentially a tornado or two. And I'm going to go into that tornado threat a little bit more now, or in a minute rather. Right now, looking at some of these mid-level winds that are fairly strong. So these winds 100 kilometers an hour here at the 700 millibar layer. So that's 10,000 feet, about 60 miles an hour. Any of these thunderstorms that do develop into those cores, that line of storms will help to mix some of these winds down to the surface. So that's where you're going to get your damaging wind threat, is from these strong mid-level winds. Now at the surface, here is the map that is going to show us why we're looking at a potential tornado risk. Surface winds tomorrow at 4 o'clock in the afternoon. You can see there's a very sharp boundary here, stretching from southern New Jersey back into southeastern Pennsylvania and into central Pennsylvania. Winds ahead of that boundary have a strong easterly component, so northeasterly here in New Jersey, southeasterly here in parts of Pennsylvania, and while winds back to the west of that boundary are out of the west-southwest. So these west-southwesterly winds bringing in the instability, the warmth. You're going to look for storms to develop right along this boundary, and then these easterly winds are going to help generate lots of rotational energy right along the boundary here. You can even see, if we zoom in one more level, the model is actually picking up on a little bit of that rotational energy here near Lancaster. You can see these little eddies spinning up on the model. Now, the model is not going to be able to predict tornadoes a day in advance. There's no reason to believe that, Lancaster, Pennsylvania, or any of these towns that are right along the front here on this map have any particularly enhanced tornado risk. But it is along that boundary that you're going to expect the greatest chance for a tornado as storms interact with that boundary. Again, it's that rotational energy that we're seeing from these winds that have an easterly component. And another way of visualizing that is with the storm relative helicity. So this is, again, a measure of rotational energy, and you can see this maximum value here in southeastern Pennsylvania, extending to the east into parts of New Jersey. This is the area to watch for potential tornadoes tomorrow afternoon and evening. Taking a quick look at our simulated radar map. Again, this is not intended to be a precise forecast for exactly what the weather will do, more as a general guide of how the overall setup should evolve. So morning rain showers, again, to the north of the boundary primarily. You could see some rumbles of thunder here in the New York, New Jersey area. That is left over from the rain currently in moving across parts of Michigan. A little bit of a lull in the activity mid-morning as the atmosphere heats up and begins to develop that instability. And then as this little disturbance comes in aloft, you're going to look for those thunderstorms to develop along that front. Again, that's where our trigger mechanism is. Instability along the south side of that front. We have our trigger mechanism in here. That's where you're going to look for your storm development. This is 3 o'clock tomorrow afternoon. And then as we move throughout the afternoon and evening, again, you're going to look for a line of storms. We talked about that boundary parallel shear vector. So that's pointing to the line of storms here with embedded cores that are going to give you those severe thunderstorm chances. Not everyone along the line will see a core. So it's going to be a matter of if you get into one of these core cells kind of embedded within that larger line that you'll be able to tap into some of those winds aloft. Parts of the cores will have large hail, damaging winds in excess of 60 miles an hour, and the chance for tornadoes here in southeastern Pennsylvania, as well as central New Jersey. Again, I talked about that with that rotational energy associated with the easterly winds to the north of that front. So plenty to watch before storms move offshore tomorrow night. That front lingers, though, and we will expect another round of some storminess overnight tomorrow night into early Sunday morning. And then a final wave is going to move through on Sunday. Currently not expecting any major issues associated with that. The model currently depicting just showers, but we could see some thunderstorm activity, especially along this sort of southwestern fringe of that, where we might be able to get some instability later in the day. I'll have more updates on that on Sunday if it looks like it'll bring any impacts of significance. That's it for me for now. Thanks for watching.